Students, this is Mr. Ivan. Okay, so this topic is about vectors, and vectors is the last chapter for your EMath syllabus. This topic can be considered hard, but it's actually, if you understand the concept and apply it accordingly to the questions, you should be fine. Okay, so before that, you need to be good in your some coordinate geometry concepts. Okay, and for some IP schools, if you need unit vector, I will do it in a separate video. Okay, so first and foremost, vectors can be converted from coordinates. Okay, so if you have a coordinates of x comma y, then in vector form the x is the top number, the y is the bottom number. A coordinate to convert into vector, we always start from O. That's because a coordinate is relative to O. So this is the x, this is the y. So for example, you have A here, which is, let's say, 3 and 5. If you draw a line from O to A and draw an arrow, this is a vector. So OA is, we write it as x on top, y below. But if you are a coordinate, then it is 3, 5. Okay, so this is how we convert coordinates to vector. Next, the magnitude. Magnitude means length. Okay, so in physics, if you keep hearing the teacher say, oh, vector is something that has magnitude and direction. What does magnitude mean? Magnitude just means length. It's just another word for using length. And in your coordinate geometry knowledge, length is the Pythagoras theorem. It's the square root of x squared plus y squared, and the units is called units. Okay, same thing. So look here, because I want to find the length of this, can you see it forms a right angle triangle? The rise over here is 5 and here is 3, so to find the hypotenuse I use the square root of 3 square plus 5 square. Okay, so over here is an example of the representation of OA and the representation of OB and the value of the magnitude. In EMath, we leave it in 3 significant figures. Next, so just now I said vectors has both a magnitude and direction, right? Just now we talk about magnitude, now we talk about direction. Okay, so it's important to know that in vectors, right, OA and AO, as long as you have a vector on top, they are not the same. Okay, because of direction. Okay, so you see PQ over here is going upwards. So PQ, this is 3, 2. Okay, then the QP, this is QP, will be called the negative 3, negative 2. You need to put a negative if you are going to flip the direction. Okay, just very simple. Just give a negative to both the x and the y value. Okay, so in this example 5.1, AC is equals to negative 3, 4. Then what would CA be equals to? Okay, you don't have to really say that it's the negative of AC. You don't have to. You can immediately write it as 3, negative 4, because the negative goes to the x and the negative goes to the y. Okay, so when you see this means magnitude is equals to the square root of 3 square plus, you don't have to write the negative for the 4, because magnitude, we are talking about the positive value. Okay, and if you know your Pythagorean triplet well, this is 5 units. Okay, units for length, not square units, that's for area. Okay, so this is a short example of how to find the opposite of a vector, opposite direction of a vector, and the magnitude. Next, when we want to find the resultant vector, okay, when we want to find the resultant vector, always look for a triangle. Okay, what do I mean by that? Now, this is A, this is C. Okay, to go from A to C, I always use this MRT example. Ang Mo Kio, you go to Bishan first, then Bishan take another train to Chinatown. So these two arrow, okay, is like the longer way to get from Ang Mo Kio to Chinatown. With Ang Mo Kio to go to Bishan first, then Bishan to Chinatown. Okay, so that's why you see AC is equals to AB. I must go to Bishan first, then from Bishan I take another train to Chinatown. Okay, yeah, so the middle two alphabets, right, must tally. I find that this is the easier way to find the resultant vector. Instead of, some of your schools will tell you that, oh, AB is equals to OB minus OA? Can. Okay, can. Essentially it's the same. Okay, I prefer to say that AB is equals to AO plus OB. I prefer to use this. Now, sometimes you don't have AO, then you just flip it yourself lor. From OA, you can flip it. That's the negative of OA, right? So you see, that's the negative of OA, right? Plus OB. So that's why some schools you are taught, oh, that's OB minus OA. Also can, if you are comfortable with this method, that's fine. If you still don't get the gist of it, then it's always good to use this. As long as the two middle alphabets are the same, it is easier to understand how to find the resultant vector. Okay, so an example like this, if PQ is equals to negative 12, 16, and RS is equals to 5 over 4 of PQ, so I say that RS is equals to 5 over 4 of negative 12, 16. So basically multiply negative 4 to both the X value and the Y value. Okay, 12 divided by 4, 3 times 5, so that will be negative 15. 16 divided by 4, 4 times 5, and that will be 20. Okay, now part B is more tricky because they say that P is a point, so it's a coordinate 10, negative 8. Remember the first thing I say today is when you get a coordinate, you want to convert it into a vector. Okay, it must start at O. Okay, 10, negative 8. Okay, then I want to find the coordinate of Q. Coordinate of Q means I'm looking for OQ. Okay, so I can write, okay, OQ is my resultant vector that I want to find. It must start with O to somebody plus some place plus Q. Okay, now we have P here, right? So it makes sense to write that it is OP plus PQ. What is OP? 10, negative 8. What is PQ? I think it's given on top. Negative 12, 16. So X add to X, negative 2, Y add to Y, and 8. Okay? Same thing for part C. You are given that S is equals to 2, 5. Okay? So which means OS is equals to 2, 5. Okay? Don't say 2 over 5. It is not a fraction. Alright? Next, the question wants to find the point of R. That means the question is asking for what is OR equals to. Again, that's why I say using addition is easier. O something plus something R. Okay? Then we have OS because you are given OS first plus SR. What is OS? 2, 5. What is SR? I don't know what is SR. But at the start, I know RS is equals to negative 15, 20. So that's what I mean by you own self go and change the sign. Plus 15, negative 20. This way, own self go and change the sign. Then you can add already, and that will be 17 and negative 15. Okay, however, these two examples that I did, the answer is wrong because the question is asking for coordinates. So please, at the end, write Q is negative 2, 8 for coordinates. R is 17, negative 15. Okay, the whole of vectors, the hardest concept to understand is this parallel property. Okay, if I so you realize just now when we did a few examples in front, when I multiply by a number in front, means the number will go to both the X as well as the Y. Okay, now what happens if you multiply negative number? So first you look at this diagram over here. A is 1, 1. If I multiply by 3, it will become 3, 3. Then you realize that, you see the length will become 3 times the of A. Okay? But if I multiply by negative 2A, okay, the length will multiply 2 times. But can you see that the arrow is in a different direction? So A and B have the same direction. Okay, because of a positive multiple. But C, because of a negative multiple, right, it will go in the opposite direction. And do you realize that all 3 vectors are parallel, okay, because the when you multiply by a scalar multiple, okay, kind of like the direction, but you know you can go negative way, but their facing is still the same, okay, but what is different is their magnitude. Okay, so that's why if the question tells you that they are parallel, if A is parallel to B with a thinking cap, that means it's important. This means you introduce a K yourself. This means that A is equals to K times of B. A bit like direct proportion when you do your direct proportion. Okay, we need to introduce K, we need to introduce a constant K and find the value of K first. Okay, we need to find the value of K first. Okay, so now the question may give you as such. They tell you that P is parallel to Q. So if they did tell you, you have to introduce yourself that, oh, P is equals to K times of Q. Okay, by right, both means you have to underline during your working. It depends from school to school, so see what your teacher says. So P is 9 negative 12 is equals to K times of M27. Okay, this means that 9 negative 12 is equals to Km and 27K. Okay, the X compares to the X. Now I compare the Y value because the X value has two unknowns, so I compare the Y value and I say that negative 12 is equals to 27K. K is equals to negative 12 over 27, okay, divided by 3 on both sides, negative 4 over 9. But that's not done, okay, that's not done. Alright, I'm supposed to look for Y. So I know that I compare X, 9 is equals to K times of M. 9 is equals to negative 4 over 9 times of M. So M is equals to negative 81 over 4, divide over, and then you can get the answer. Okay, now, even if you gotten M already, don't neglect the importance of K. Okay, don't neglect the importance of K. We have found that K is equals to, here, K is equals to negative 4 over 9. At the very start, when P is parallel to Q, this means that P is equals to K times of Q. We have also found that the K is negative 4 over 9 times of Q. Okay, now what does this mean? This means that 9P is equals to negative 4 times of Q. Alright? P is definitely smaller because I need 9 units of P to make 4 units of Q. So this is P. Okay, now Q is in this direction, but they are parallel. It's just that it's in the opposite direction. This is Q. Okay, and what can you say about the magnitudes of P and Q? The magnitude of P is to the magnitude of Q is 4 is to 9 because 9P is equals to negative 4Q. The negative, don't worry, the negative is just an opposite direction only. Okay, the negative is just an opposite direction only. So the magnitude is 4 is to 9. The P has 4 units and then the Q has 9 units. If we want to show that two vectors are parallel, so it's the opposite of just now. Just now, if the question tells you, oh, P is parallel to Q, then you say that P is equals to K times of Q, right or not? Okay, then the opposite is true. That means if I can say that P is equals to K times of Q, right, then it means that P is parallel to Q. Do math, we must do two sides. Expansion must always come with factorization. Okay, do math must always do two sides. Okay, so the trick is we try to factorize out a K from the bigger vector. This is how we show that two vectors are parallel. Okay, so you see some form of factorizing is now AB is equals to 5 negative 15 and CD is equals to 1 negative 3. It's very obvious that you can factorize out a 5 from AB, right now. So AB is, you take out a 5, 1 negative 3, and then 1 negative 3 can be replaced by CD. Okay, so what does it mean? I found that AB is equals to 5 times of CD. Okay, AB is equals to 5 times of CD. In graphical representation, it doesn't matter how the vector points, because you're actually not required to draw, but understand that AB would be longer, CD would be shorter. Okay, so this is A to B, and then this is C to D. So this is 5 unit, and then this is 1 unit. So once you can say that they are 5 times of something, you say that they are parallel. That's it. Okay, this is something I want to bring across to you, is that the magnitude, the ratio of the magnitude is 5:1. It doesn't mean that AB is 5 units, the length. It's just that the ratio is 5:1. It could be AB is 25 and then CD is 5. It could be something like that. Okay? Vectors can also be expressed in A plus B form, or A minus B form, or P plus Q, P minus Q form. Okay? So same thing. You see, I have 3A minus 12B. And I have CD is equals to 2A minus 8B. Of course, I know that 3A minus 12B is bigger. Okay? So, I need to make it mathematically equal. Okay? Assuming that I do not know what is the constant here. Okay? Now, 3 must get to 2. Okay? So, how do I get the constant here? Something multiplied by 2 must give you equals to 3. Something multiplied by 2 must give you equals to 3. So the something is equals to 3 over 2. And that's why the K outside is called 3 over 2. Okay, and yeah, so you always try to make the inside bracket, right? The guy that is given there, the CD that is given. Okay, so that you can say that, oh, it is a K times of the bigger vector is a K times of the smaller vector. Once you can say that it's a K times of the smaller vector, we say that hence they are parallel. The ratio of the magnitude is not that important, okay? The ratio of the magnitude is not that important. So hence, that's why I say here, usually the question after asking you to show that they are parallel, right? Or in the next part, you will learn that they show that they are collinear. They will ask for 2 facts, okay? We will say that number 1, they are parallel. So that's the first fact that they are going to give you, okay? And then number 2, express the ratio of the magnitude, okay? Whenever you see the question ask the ratio for the magnitude, right, use this factorizing method to show. Don't need to not necessary to find the magnitude of the vectors. So in this next example here involves adding and multiplying and subtracting of vectors. Okay, for part A, the question is asking for 2p plus q. So all I need to do is to express it properly. 9 negative 12 plus negative 627. Okay, so just use your calculator. 2 multiplied by 9, 18, then minus 6. That will be 12. Okay, then followed by the bottom number, negative 24 plus 27, and that will be 3. Okay, so over here be very sensitive. You know something can factorize already. Okay, you know something can be factorized already. Okay, next the question wants p minus r, and that would be 9 minus 12 minus 5 negative 13, and that will be equals to 4 and 1. Okay, yeah, so B is actually a leading step. They ask you to show that it can be a K times, the first vector can be the K times of the second vectors. So 12, 3 is equals to 3 times of 4, 1, which is equals to 3 times of P minus R. Okay, so which means 2P plus Q is equals to 3 times of P minus R. Okay, and what are the 2 facts? Remember, the first fact is 2P plus Q is parallel to P minus R. That's it. Okay, what's the second step? The magnitude, the ratio of the magnitude P minus R is 3:1. Okay, remember 2P plus Q is bigger. Okay, or actually some of the schools just wants you to say that, oh, 2P plus Q is equals to 3 times of P minus R, then that's fine already. Okay, but this showing the ratio is actually more elegant. Okay, it's actually more elegant. Alright, so this is how you do show that question. Okay, I'll leave you to do examples 5.2b and 5.2b part 3. Okay. So next, collinear means they all lie on the same straight line. Collinear would be the same as proving parallel because they are all in the same direction. Okay, they are all in the same direction. Okay, they are all a scalar multiple of each other. So same thing, you see, I try always factorize a constant out from the bigger vector. Okay, and then again the ratio of the magnitude is optional. Okay, now how do you explain? The difference part is you say that AB and AC are parallel and they have the same starting point A. So that's why A, B and C are collinear. Okay, so that's why A, B and C are collinear. Okay, so for this example, I think you can factorize, find out the ratio and list the two facts. The difference is because they all start at the point A, so that's why they are collinear. So now, if they are collinear, you say that they are collinear. Don't say they are parallel. Parallel doesn't mean collinear. Okay, but collinear means parallel. Okay, and we come to the last part in terms of concept. Now, very common in the last part of vectors question, they will ask you to find the fraction of triangles and figures. Okay, so it can be broken down into three cases. The first case is see if the two triangles are similar. Now remember, what is the easiest proof for similarity is AA. That means in this figure, this angle is the same common angle for this red triangle as well as this blue triangle. Okay, and then because they already say that this and this are parallel, right? Okay, that means this angle and this angle are equal because of corresponding angle. Now, usually they will ask you to prove this. Usually they will ask you to prove this by using the parallel property, the factorizing part. Okay, so once you prove already, right, or 2PR, okay, is equals to 3QS. Okay, so it's good to write the numbers here, 3 and 2. Okay, now I know that they are similar. Then remember the concept. If two triangles are similar, then the ratio, the fraction is L1 over L2 square. Okay, so for this is just 2 over 3 square equals to 4 over 9. That's it. Okay, and it also means that this one is 4 unit. I circle down here, and then the blue guy, the blue triangle, the whole thing is 9 unit, and I circle down here. So that's meant for the triangle. So if the red one is 4 and the 9 is the whole big triangle, this means that the trapezium here is 5 units long. Okay, so if the questions ask for the triangle over trapezium, then you know that the trapezium is 5 units. Just minus off, that will be fine. Okay, so that's case 1. Case 2 is they are not similar, okay, but you can see that they share a common height. PT is equals to 3 of PQ. Again, maybe this part of the question they will want you to prove. Okay, they will want you to prove. So I know that PT is 3. Okay, but seldom we write the number 3 there. We will write like 1 here and then 2 here. Okay, now I already draw that there's a dotted line here, that is the common height. For this triangle, right, for this triangle, why is it common height? And that's because many of you forget that in your sec 1, right, to find the area of triangle, this is the base. And then the perpendicular height is here. Okay, it's outside. So it's called a scalene triangle. Okay, of course you can take this as the base, but it does not help you. Okay, so in this case, if you know your similarity and congruency topic very well, then you know that, okay, so for POQ, I will put POQ in green, okay, over POT in red. Okay, so they have a common height and an overlapping base. The base of POQ is PQ. The base of POT, the red one, is PT. So you realize that half and half can cancel, height and height can cancel, and it's just the ratio of their length, which is 1 over 3. Okay? now I will clean away the red one. Okay, so if the question wants these two triangles, then it's very straightforward. In fact, you don't even need to write this or this. You can immediately state the answer 1/2 if you understand the concept. Okay, because it's half times the base for the green one is PQ. Sorry, the base of the green one is PQ, and then the base of the blue triangle is QT. If you are not confident, then we just do this law, then we cancel, and then you can see very obvious is 1/2. Okay, and sometimes, in fact most of the time, you will have a part 3 when the two triangles are totally not related. Okay, again, some of the information is given to you, and some of the information you need to do the factorizing to prove. BD is 2/3 of DA. So BD is here. Sorry, let me use red for this. BD and DA. So this is 2 unit and then this is 3 unit. I will always write the numbers on the line. Then I will go to the other one and then see that OD is 1/4 of DE. So this is 1 and this is 4. Okay, see, as long as you write the numbers there and then you know which line we're talking about, is very important. Okay, now the triangles that we are looking for is ODA. So it's also good that you do this part, ODA. Okay, against I will use maybe black, DBE. Okay, so when you are going to do a question like that, right, always ask yourself, number 1, are they similar? Obviously they are not similar. Okay, number 2, do they share a common height or not? Do they don't share a common height? So that's where case 3 comes in. Okay, we observe that ODA and DBE, they can form a relationship with this triangle. Okay, so maybe you take your hand and cover this side. Let's cover this side. Can you see that ODA and ODB? Okay, they can be used. You can use case 2 to find the ratio of their triangle. Okay, same thing. Now I erase here and I cover this side. Okay, can see that BDE and BDO. Okay, they can form a relationship using case 2. Okay, so that's why in order to solve this kind of question where they are not related, right? Okay, your thinking process is now. Okay, ODA, which is the green one, must be the numerator, so I keep it as a numerator. Okay, DBE, which is the black one, okay, is here. Over here in these 2 empty spaces, it must be the same triangle so that you can like cancel and cancel away. They are mathematically equal. Okay, and just now we have already established the fact that they have the same triangle that they can have a relationship with is ODB for the green triangle and as well as ODB for the black triangle. Okay, so now I use case 2. Okay, so let me cover here. What is ODA over ODB? What is it? So if you understand case 2 very well, you can immediately just write that it's going to be 3/2. Okay, and same thing. What is ODB over BDE? Okay, equals to. Now we will erase away the part that is blocked and then we use our hand to block the other side. You can you see it's 1/4 because we use case 2. Can you see the ratio of their side? Very obvious. I just write it down there, multiply together, and I get 3/8. Okay, and this is how you learn all the vectors concept, okay, within half an hour.